Hello and welcome, I'm your Code Monkey, and here let's learn how to use the animation rigging package. This is an extremely useful package to help make your game feel much more polished by adding all kinds of dynamic movement on top of your animations. You can easily make your characters look at a moving object, or maybe grab a dynamic item from the scene, or make a skeleton with a chain of bones, or a character in a third-person shooter make it aim perfectly. The package is excellent and really easy to use, the final results look great, and they definitely make your game feel much more polished. Also, this video is a lecture taken from my Ultimate Unity Overview course. Unity is massive, so in the course I explain over 50 features and tools of the engine that you might not know about. There's individual lectures explaining tons of things like shadograph, assembly definitions, animation avatar, video player, and so on, as well as many other niche things that I couldn't possibly cover in normal YouTube videos. Also, the course will continuously be updated with free updates as I add more lectures explaining more tools and features. This specific lecture was added as part of the second free update that explains more tools and features. So go ahead and get the full course to learn how to master all of the Unity tools to help you make better games faster. In this lecture, we're going to learn all about the animation rigging package. This one is an extremely useful package that makes a bunch of complex animation logic very easy. It's all about adding dynamic animations on top of your static animations. So for example, having a static, normal, idle animation, but then making the head point towards a dynamic object moving around the scene. It also helps you handle IK, or inverse kinematics. So for example, you move the hand, and automatically the upper and lower arm moves to where it makes sense. So let's first look at how to install the package and browse some of the official samples. Then after that, let's learn how to create 3 scenarios. How to make a head look at a dynamic object, then how to make a leg bend with IK, and finally, how to combine it all to make a character aim perfectly at a target. Okay, so let's do it. Now, first of all, this one is a package, so you get it by going through the package manager. Up here, make sure you select the Unity registry, and then simply find the animation rigging package and hit on install. When you install it, then you should be able to see a menu up here called animation rigging, so it's installed. Now also on the package manager, over here you've got a samples, so you can import these. These are extremely useful for seeing all of the various use cases. When you import them, it adds a Unity folder, and then inside you've got the samples for all of the various things. So here it is, all of the scenes showcasing tons of different scenarios. And on top of that, in terms of documentation, it also adds a really nice README file. So as you can see, there's tons of demos, all of them with nice description here telling you exactly what they showcase. So let's see some of these demos. For example, here is the simple aim demo. So in this one, there's a simple object moving around the scene. Then as you can see, the head of the character is constantly pointing towards the object, and same thing for that little cannon. It's always pointing perfectly towards a moving object. Now you can obviously inspect all of this to see how it's all set up. So over here the root model has a rig, and here is the aim head component, which is using a multi-aim constraint. So it's constraining the head bone, and it's pointing towards the aim target object. And all of it is set up, and same thing for the gun, just doing the same thing. Now, the main goal with this package is that this is not a pre-made animation. So I can stop the ball from animating, I can place it anywhere in my scene, and as you can see, the head and the cannon always looks perfectly, so I can put this anywhere and everything works. So the animation rigging package is automatically calculating how to rotate the head bone and the cannon bone, how to rotate it to make it face towards a dynamic position. And this sample is also showcasing leg IK, so the animation on these legs is being driven by these target objects. So the animation is just moving up and down, and then these cubes, and the logic is calculating where to put the knee, the bones, and so on. Then here's another sample showcasing the chain IK. So it's a scorpion with a ton of bones that make up the whole tail. And again, the animation rigging system, there's the target moving around, and the system is being used in order to make sure that the tail hits a very specific point. So as the thing jumps about, there you go, it hits it. So here you can see how I can place the target anywhere, and all of the bones go to where it makes sense. The animation rigging package is constantly calculating where the bones need to be in order to make sure that it hits this point exactly with the tip. So as you can see, all of these demos are super useful, and the official documentation is also excellent. It shows very clear examples of what each constraint does, how it works, and what each setting does. Okay, so with all of that, let's learn how to use it. Over here, I've got my character, and it's just playing a basic idle animation. Now, let's build one of the simplest things you can do to add a bit more life to your games. Let's just make it so that our character can look at a dynamic object. So the character is all pre-standard, it's got a basic animator, then inside there's a skin mesh renderer with the actual visual, as well as a simple humanoid rig. I cover animations and animator in detail in other lectures, and this character is from Mixamo, which I also covered in the animation avatar lecture. So first of all, the way animation rigging works is based on creating rigs. So let's select the main character game object, then go up here into the animation rigging menu and hit on rig setup. As soon as you do, you can see that on this game object it adds a rig builder with a reference to a rig, and this is a game object that was created which has a rig component. So this is the rig, and now inside our rig this is where we can add any constraints that we want. So for example, inside the rig let's make a new game object, call this the head aim. And then just go up here into add component. Let's go inside animation rigging. And now for this case, we want the head to aim and look towards the target. So let's pick the multi-aim constraint. Now we have all of these fields to set up our constraint. Starting off with the constraint object, this is whatever bone we want to constrain to aim towards something. Now thankfully on the animation rigging package, there's also a really helpful tool included. You can select the main game object, then go up here into animation rigging and click on the bone render setup. And yep, this is super useful. This adds a really nice visualizer for all the bones. And over here on the component, you can change the color, change the shape, size, and so on. So this is a super useful utility to be able to see exactly all the bones that make up the character. And also super useful is that if you click directly on the bone, it actually selects the bone. Whereas if you don't have this and you click on it, it just selects the skin mesh render. So this is super useful. Okay, so now that we can see the bones, let's set up our constraint. Over here in our settings, the first one is the constraint object. So this is whatever bone we want to apply this constraint to. Now in this case, we want the head. So let's just pick the head bone. Here it is, the Mixamo rig head, and just drag that reference. Next up, we've got the aim axis and the up axes. These are the axes that the animation rigging system will use in order to correctly point towards the target. Now if you get issues, for example, your character is pointing towards the target using the top of the head instead of actually looking with the face. If you get issues with that, then you play around those. If you want to figure out which axis you should use, just go ahead and select the head bone. Then up here, you've got this really nice button that swaps from global into local. So this changes the world space over here on the tool handle. So you can see on global, if I move over here to the right, then I'm moving on the X, then the Z isn't there and the Y isn't there. But this bone or any parent bones might be rotated. So if you click on local, then you see different axes. So this is the one that you have to pay attention to, so make sure that one is in local. So over here we can see that the one pointing forward is over here the blue one. So the blue one is the Z axis. So this is the one that we're going to use for the aim. And for the up, we've got the green, so in this case is the Y. So point forward on the Z and aim up on the Y. So over here, let's set it up like that. So the aim axis is on the Z and the up axis is on the Y, okay? Then for the warm up type, for this one you probably don't need to play around it. Then the next important setting is over here the source objects. So this is the actual target that you want to look at. So for that, let's make a new game object inside of our head aim and just call it the target. Now this one doesn't have to be a child of this game object, you can place it anywhere, but in order to keep things organized and putting it in here makes sense. So just create it and just drag the reference. So here's the target and now we can move it around. One more super useful thing in this package are the effectors. So over here on the lower right corner on the scene view, you can see this little tool window, and over here you see the plus button. So if you click on it, now you can add an effector for this game object. So this is kind of like a visual gizmo. You can click on the little circle icon and just choose. You can use any mesh you want, but there's also a bunch of effectors included in the package. So you can search for effector. And now over here, if you don't see anything, that's because this button, so it's not showing hidden packages. So if you type in effector and you don't see anything, make sure you tick here so that it actually shows the hidden ones. And if you got these for included ones, so you can use a box, so there you go, a nice little cube there. Or you can go with a ball, with a simple 2D circle, with a locator, just a nice cross, or a simple square. Now for this case, for target object, let's go with a ball, that looks pretty good. Then again, you can play around the color, size, and so on. Okay, so this way we've got a real nice visual to make sure that we see where the character is looking at. Now in the rig, we still have a bunch more settings, but just with this, everything should already be working. However, another thing related to the animation rigging package, which is just like this. If I move the target, you can see it's not actually working. And actually here I made a slight mistake. This gizmo should be on the target, not on this game object. It's a target that we're going to use, so let's actually remove it from this one and add it over here. And also one more thing that you might be seeing these images. These are the gizmos for the rig component and the various constraints. These can be slightly annoying, so while you're setting it up, if you want, you can just disable gizmos up there. Or you can manually go here and find the various constraints. So for example, over here, the multi-aim constraint, you can just hide this gizmo individually. So either do it individually or hide them all. So just to keep things nice and clean, okay? So as I was saying, the way that animation rigging works, Just like this, if I now take and I move the target, you can see the head is definitely not looking towards the target. Now there are two ways that we can see the animation rigging in action. Now one way is obviously by hitting on play and playing the game, but another one that might also be very useful is if we are in the animation preview state. So over here I've got the animation preview window, and if I click over here on the preview button, now there you go, the character actually goes into the animation preview, and while this preview is active, now animation rigging is indeed working. So this one is great if you want to continue setting up the animation without having to hit play. Just make sure you go into the animation window and enable preview. And yet another thing that you should learn about how animation rigging works is that the way this works, since it's all based on jobs in order to make it super performant, since it works like that, it means that if you change any settings over here, they won't be applied immediately. So for example, let's say that I want to aim with the top of the head instead, so let's put it maybe on AY. And now if I move the target, then nope, it's still working exactly the same as previously. Again, that's because we were already on preview, so I have to leave preview mode and now re-enter, and yep, now it is indeed using the new settings. So that's another specific thing for how animation rigging works. So as you can see, I need to exit and re-enter preview, and same thing for playing. So right now the game is playing and the character is aiming like that, but if you go over here and you swap it back, and nope, it didn't actually change. That's because these changes are only applied when the actual game starts running. After it starts running, you can't really change this. So swap this one back into the Z, hit on play, and yep, there it is. Everything is already working. So I can take this target object, I can put it anywhere, and yep, it looks perfectly. So I can look left and right, up and down, I can look anywhere, and yep, the character always looks perfectly towards the target. And again, keep in mind that the character is still playing the basic idle animation, so the animation itself doesn't have any of this dynamic movement. It's all being handled by the animation rigging package. Alright, awesome. So for example, you can see how this very simple use case would be extremely useful for things like, for example, having this character talk to the player. So let's say the player was right there and the character is looking at it. That makes it much more immersive than if the character is always pointing straight ahead and the player is off to the side. Then the player could even move and the character would continue looking at the player. Or maybe, for example, this one is a player and there's an item to grab right there on the floor. So the player can look at that and make sure that it's looking directly at the object. So again, just with this very simple example, you can already see tons of potential use cases. Okay, now for these other settings, there are two offsets. Now the first one, maintain rotation offset. So if this one is unticked, and over here, look at how the target is to the left of the character. If I hit on play, then the character starts looking perfectly towards the target. However, if I now enable this, now it's essentially going to keep this offset. So when I hit on play, yep, the character is now still looking forward. So it's essentially applying the offset to this target as it was when I hit on play. So now if I move, it's still looking, it's essentially applying the offset that this object had when I hit on play. And then you have an actual offset. So this one will essentially make the character look towards that object plus whatever offset is in here. However, for some reason the scale is strange. So if I put just 1 on the Y, you would assume it would look around 1 unit above, so it should look around here. But no, it's still looking pretty much perfectly towards that one. So this is working, but for some reason, the scale in here is a bit weird. If I put it on 50, you can see that it is indeed working. So right now it is working, although once again the axes are slightly different depending on the bone. So adding 50 on the Y over here on this constraint, adding that apparently adds here left to right. So if I look left and right, you can see it's always looking slightly to the right. So here if I put minus 50 on the X, now it is indeed looking above wherever I put the target. So for example, let's say you want the character to look towards a really tall something, you can put this on the base and simply add the offset. So the scale over here is very strange, but it does work exactly as intended. Next up over here, we've got the constraint axes. So this is which of the axes will be affected by this constraint. For example, right now, if I hit on play, and if I take the target and I put it somewhere right next to the bone, you can see how the head is rotating like that. So left and right, way too much. Let's say you only want the head to actually go left and right and not like this. Then over here, you could disable the axes. So for that one, that would be the Z axis. And now if I try putting it on that same place, you can see, yep, the head no longer rotates like that. It only goes left, right, up, down. It no longer shifts to the side like that. Or for example, let's say you only want it to look up, down, and not left, right. Then for that case, you would disable the Y axis. And yep, now the head does look up and down, but it does not look left and right. And the final one we have here are the rotation limits, so the minimum and the maximum. So for example, a normal human head usually cannot rotate 180 degrees, so this is not human-like behavior. Usually the head stops roughly around there, so roughly 90 degrees. That's pretty much how much your neck can actually rotate. So you can set it here. For example, say go from minus 80 to plus 80. And now if you take this and put it straight behind, nope, once it gets to minus or plus 80, then it no longer rotates more. All right, great. The next thing that we see is over here, the constraint has a certain weight. And then if you look in the rig itself, the rig also has a weight. This is how you define just how much impact this rig or this specific constraint has on the final thing. So for example, let's say the goal here is for this character to look at an object. So we would place the target directly on the object. But then let's say that we only want the character to look at the object when close enough. Well, we can easily do that by modifying the weight. So if the weight is at 1, then it is indeed looking straight towards the object. But if the weight is slowly going down to 0, then nope, now it's just playing the normal idle animation. So the character would be like this, then as the character moves forward and approaches the object, then you would slowly increase this one, and yep, now it's looking towards the object. So that's a super simple example that adds quite a bit of immersion to your game, and it's also super simple to do, so let's see how we can do that through code. Over here, let's make a simple C# script. Call this look at object animation rigging. And now for attaching the script, let's attach it directly over here onto our rig, okay? So now here, the only thing that we need is a reference to that rig component, which also means we need to find out where this rig class exists. If over here, if I just do a private void awake, and on awake, I try to get component of type rig. If I just do this, then nope, it does not work. It does not recognize what is a rig. So that means we need to find out how we can access this class. And I actually covered that in another lecture. I covered how you can find any class for any tool and feature. Definitely go watch that lecture if you haven't seen it. So here you can just right click on the rig and go into edit script. And when you do, yep, it opens up the actual script. So with this, we can now see that this one is inside the Unity engine animations rigging namespace. And then the rig component itself is named rig. So all we need to do is add this using. So over here, just add using that, and there we go. Now we get our rig component. Okay, so with this, let's just make some simple code for modifying the weight. Okay, so here it is, some very basic logic. So as I press the T key, it's going to set the target weight to 1. And as I press the Y key, it's going to set it to 0. Then I'm just using mathf.lerp in order to have a nice smooth interpolation instead of being instant. So that's it, very simple logic, let's test. So here we are, and there's the character playing the normal idle animation. Now let's say the character approaches a certain NPC, and I press the button, and yep, now the character is looking towards where that character would be. Now let's say the character moves away, and yep, back into playing the normal idle animation, just looking forward. So you can see how easy it is to play around with all of your constraints through code by just easily playing around the weights. This simple example alone is already great for adding that extra bit of polish to your game. Okay, now let's build another very common example for IK. Let's make some foot placement. Here is my character again, and again, let's add a rig. So go into the menu, rig setup. Okay, automatically adds the rig, all right. Now inside the rig, let's make our game object. So create a new empty game object. Let's call it foot IK, and then go into add component. And in this case, we're going to use down here a 2-bone IK constraint. So this one, as you can see, takes a root bone, a mid bone, and a tip bone. So for a leg, this would be the hip, and then the knee, and then the foot. And if we were to use this on an arm, then instead this would be the shoulder, the elbow, and finally the hand. Now there's also a really useful tool for this component. Instead of having to assign all of these and create these source objects, you can just start by assigning the tip. So in this case, we want the leg. So let's select this bone right here. So we've got our right foot. So just go in there, assign the right foot onto the tip, and then right click on the constraint itself, and then down here, auto setup from tip transform. And when you do that, yep, it automatically fills up all the other ones. So it goes from the tip and essentially automatically chooses the 2 parent game objects above it. So we've got the left foot, then we've got the leg and right up leg. So you can see the foot down there, the leg, that's that bone, and that bone. Okay, so all of that is correct. And it also automatically creates a foot IK target and a hint. Now the target, this is where we want the foot to actually be placed. And then for the hint, this is kind of a soft target meant for the middle joint. So in this case it would be the knee, and if we were playing with an arm, that would be the elbow. So based on how humans work, you would want this one to be in front, since human knees generally don't bend backwards. So you would place this one in front, and then the target down there. By the way, this one is also optional, so you can choose not to use the hint, and if you don't assign it, then essentially the animation rigging system will try to guess where the knee should bend to. Okay, so that's pretty much how easy it is to set this up. Now again, we can use down here the really awesome gizmos. So let's place one on the target. For target, let's go with the box, and for the hint, over here, let's go with maybe a locator effector. Okay, so here we've got the target for the foot, and over there we've got the hint. So just like this, with this very simple setup, so all we did was assign the tip and then use the menu. So just with this, if we hit on play, and yep, just with this, as you can see, it's already working. Now, this specific IK also takes the rotation of the final object into account, so that is why the leg over there, the foot, is looking very strange. So just rotate it to make it a bit more sense. Okay, so like that, the foot is looking kind of normal. And again, like you see, that effector, the hint, is used for where it should bend. So right now, if I move the leg like this, then obviously it makes sense, so the knee is bending correctly. But if I put it above, then that goes backwards. So that's essentially how the hint is used to make this. So in the case of a humanoid, that's pretty much all you need to do. Then over here, you can see how easily you could animate just this final object, and the leg would correctly move to match. Then of course from the side, you can see that it matches up not just up and down, but also from side to side. And then over here, the hint also has an impact going left and right. All you need to do is just put it like this, and yep, there's another perfect leg. So this is yet another super useful constraint, the 2-bone IK constraint. So this one, as you can see, is perfect for handling foot placement. So for example, let's say this character, instead of being just on a flat plane, it was actually on some kind of hill. So in that case, you wouldn't want the foot to be straight flat on the ground. If it was a hill, if it had something, then you could easily apply some rotation and maybe move it a bit. And that way the foot would match perfectly with whatever surface you're walking on. So this one is super useful. Or of course, as you can see, this one is just a 2-bone. So those 2 bones can be a foot, or it can also be an arm. So you could apply this constraint onto an arm in order to very easily grab a dynamic object. Okay, and now let's build one final common example. We want to make a weapon aim perfectly at a target. Over here is my character with a simple aim animation. As you can see, the aim is fixed, so the character is just aiming forward. Now that's not very good. You want the character to be aiming at an exact position, not just a generic forward. So let's say if the target was down here on the floor, you wouldn't want it to be aiming in that direction. So once again, we can use animation rigging to take this basic static animation and make it aim perfectly towards any point. So again, we select our character and we go and set up our rig. So rig setup, all right, we have our rig. Now inside, let's first make an empty game object. Let's call this our aim rig. And then over here, we're going to add a component. And once again, we're trying to aim somewhere. So let's use a multi-aim constraint. So just like we did on the very first example. Now we need to set the constraint object. Now for aiming, we're going to want to aim with the hand. So let's use the right hand. So let's go into our constraint and drag the hand as a constraint object. And by the way, as you can see, the weapon is over here. I've got a nice weapon prefab and it's placed as a child of the hand game object. So as this one moves, you can see that the weapon moves along with it. So all we need to do is rotate the hand and the weapon will rotate with it. Now again, over here, we need to play around with the aim axis and the up axis. And again, in order to identify which one you should be using here, you can go ahead, select the right hand. And once again, make sure that up here, you're in local. So you can see everything. And over here, we can see that the green one is the one pointing forward. So the green one is the Y axis. So let's go up here. For the aim axis, let's go with a Y. And then for the up axis, we've got over here the red one. That's the X, but it's pointing down. So pointing up, we would want a minus X. So up here, put minus X, and that's it. Now the final thing that we need is just our target. So let's make an empty game object inside of this. Let's call it the target and just drag the reference. And again, let's add a nice effector. Okay, so there's our target. And just with this, let's hit on play. And yep, right away, you can see the hand is indeed aiming perfectly towards the target. So I can place the target anywhere, and yep, the hand actually aims correctly towards it. So I can put it up, down, left, right, and yep, the target is always perfectly aiming. All right, that's great. Also, here's a quick tip if you want to verify that it's aiming correctly. You can go, for example, on the right hand where we're moving, and over here, let's create a cube inside of it. And then you just make it really thin and pointing forward. So in this case, pointing forward on the Y. So you can do it like this and really increase the Y massively. And you can see, yep, it is aiming perfectly. So now as I move this, yep, you can see it's always aiming perfectly. Go up, down, and it's always perfectly intersecting. So just a quick tip to ensure that it is aiming perfectly. And if it isn't, then of course you can either play around with where you place the aim target, or again, over here, like we saw on the settings, you can play around over here and add a slight offset. Okay, so what we have here is indeed working. So as you can see, the weapon is perfectly aiming towards our position, but of course it looks quite a bit odd. Right now, the only thing that is turning is just the hand. So the rest of the body is static. The second hand is also static. So just like this, it's not enough. It looks still quite a bit odd. Just like in real life, you wouldn't aim just by moving your hand. You would actually move your entire body. So let's do that. On our same rig, we can create another empty game object. Let's do the body aim rig. So we're going to want to rotate the body. And once again, let's add a component, animation rigging, and once again, use the multi-aim constraint. Now for the bone, this time we want to apply it to the hips. So let's see over here, the spine. So that's good. So just select the spine. And once again, let's play around with the aim axes. So make sure this one is on local. Okay, so the forward is the blue one. So that's the Z. So over there, forward on the Z. Okay. And the up one is the green. That's the Y. And yep, that's already correct. So on the source object, let's use the exact same one. So up here to the target, just assign it. And that's pretty much it. So let's see. And yep, now it looks quite a bit better. So as you can see, now the chest does rotate to face the target. So it's no longer 100% static. So pointing up, down, the chest rotates along with it. So that's great. However, you can also see that over here, the hand is no longer perfectly pointing. So the hand is definitely not pointing in that direction. So the hand is definitely looking very strange. Why is the hand looking like that? Now, the reality is that this has to do with the order in which the system calculates the rotation for all the joints. Basically, what is happening right now is the hands are rotating to face the target perfectly. So just like before, it's still doing that. But the issue is that after the hand is rotated, then we're rotating the body. And of course, the hand is connected to the body. So by moving the body, we are once again moving the hand. So in the end, after the body rotates, the hand is no longer facing perfectly. Now, the issue here is that we're rotating the hand first and then the body second, when really we want to reverse. We want to first aim by rotating the body, and then we want to aim the hand perfectly. Thankfully, that is super easy to solve. The order in which the rigs are evaluated is based on the order in the hierarchy. So all you really need to do is take the body aim and just drag this game object and put it above the aim rig. So that's it. Now it's going to calculate the body aim, and then it's going to calculate the hand aim. And yep, there it is. Now the hand is indeed rotating perfectly, so it's perfectly aiming towards the target. And as you can see, the body is also rotating. All right, awesome. Everything is working great. However, the body is also rotating a bit too much. So this is kind of personal preference, but like this, the body is rotating perfectly. So I guess if you want your character to look really mechanic, then maybe this is it. But if you want it a bit more natural, then lowering the rotation by a little bit would probably be best. Thankfully, that is something that we can easily do. We can go into the body aim rig, and over here we've got the usual weight, so you can just lower this down. We still want it to aim, just not aim perfectly, so maybe let's say 0.7. And now as we move the target, yep, the body rotates, just not perfectly. So it rotates just enough to be natural, whilst the hand still points perfectly. All right, great. Now there's just one last thing that we need. Right now the chest and the hand, they are rotating, so they look great. But of course the other hand is not moving at all, so that looks very strange. The character is supposed to be holding the front end of the rifle with this hand. Once again, we can solve this with another constraint. Let's make another one, so another empty game object. Let's call the second hand rig. And over here, we are going to add an animation rigging. We're going to make a 2-bone IK constraint, so just like we did for the legs. Now set it up. Once again, we can just set up the tip. So for this one, we're going to want the other hand. So let's select the left hand. Okay, so let's go into this one, select the left hand, put it on the tip. And then once again, use the super useful tool, so auto setup. All right, and it automatically creates our target and our hint. Now for this, we want to grab directly on the weapon. So let's take both of these game objects. Instead of being child of this object, let's make it child of the right hand. Okay, and now we just need to position them. So let's put them right on the hand. Now we just need to play around the position. So let's hit on play. And yep, as you can see, the second hand is there. So now it's really just a case of rotating this one to where it makes sense. And then same thing for the hint. We want the elbow to rotate from the other side. Okay, so when it looks correct, we can just copy the position on this one. So let's select the target, and over here we're going to transform, and just copy the component, then stop playing, then select the target, and up here, right click and paste component values. And now it should be placed on the correct place. And if we hit on play, and yep, the second hand is there, and let's just play around the hint. So let's put it slightly there, so that's how the elbow should bend. And once again, just right click, copy this one, and paste it back. Alright, so here is our final result. We've got our target, I can put it anywhere, and as you can see, the character is always aiming perfectly. So I can move up, down, left, right, and everything aims perfectly. So the body rotates, the left hand, the right hand, all of them rotate, and everything aims perfectly. And again, keep in mind that the animation itself is just a simple static animation pointing straight ahead. It's the animation rigging system that is overriding the animation to make all of these bones aim perfectly towards the target. So I can put it anywhere and always aims perfectly. Then of course you can combine what we learned here with what we learned in the animation avatar video. In there I teach you about how to use avatars and avatar masks to make essentially a separate layer from the upper body and the lower body. So that's how you could make the upper body exactly like this, so just rotate and aim perfectly, and then leave the lower body playing an idle or a movement animation. And just with that you would have a very good character aim controller. So here it is, really nice, extremely useful, the character aiming perfectly. Now let's see a few more things that this package can do. So far we've been looking at how it's used to dynamically apply changes to the animation. That's one of the best use cases. But this package can also be used to modify any animation you already have. So there's a way to modify the actual animation itself rather than making it dynamic. Meaning that you can essentially bake the constraint motion directly in the animation. That way you're not spending any processing power running the rig. So here is another scene from the official samples. This is the twist chain. So it shows a twist chain constraint. And on the animation, as you can see over here, the only keyframes are for the root and the tip. So these objects are the only thing that's animated, and then the animation rigging package decides how to move all of these cubes that make up the chain. Now let's say you want this exact animation every time. Maybe you're making a cutscene animation and you don't need anything dynamic. If you don't want it to ever change, then there's no reason to spend processing power running the animation rigging package. So instead you can bake this exact animation directly on the animation itself. To do that, just select the animation over here on the animation window, and make sure you have a duplicate so you have a backup if you need it. And then you can select the root, and then you can go into the rig builder and right click. And over here you see this option, transfer motion to skeleton. And if you choose it, and yep, it automatically created all of the keyframes for all of these objects. So if I hit on play, I still get the exact same animation, although right now you can see that over here the rig weight is set to 0. Meaning that this rig is no longer used, so this whole animation is baked directly into the objects themselves. And in order to bake, like you saw, we can do it over here on the rig builder. So select the object on the rig builder, you can do this. But you can also do it over here individually on each rig, or even individually on each constraint. So you have all of those options for baking. And after baking, you can even delete all the rig components. So you can delete them on the animation itself, delete all of this. And then just here, delete the rig, and go into this one, delete the rig builder. And if you hit on play, yep, there you go. You can still see the exact same animation. Everything works perfectly. So this is another super powerful use case for this package. You can essentially modify any animations you already have. However, there is one pretty important limitation with this utility. It does not work on humanoid characters. So over here, back in the previous scene, this one is using a humanoid rig. And if I right click, nope, those options are grayed out. However, on the forums, I did found a slight workaround if you absolutely need it. According to this official response, the bidirectional baking on humanoid characters is not on the roadmap. But as a workaround, you can use the FPX exporter. So using that, apparently you can bake the constraints back into a generic rig as opposed to a humanoid rig, and then it should work, and then re-import them back as humanoid. So if you absolutely need to do exactly that, then maybe this is the way to do it. Okay, so we just saw how you can turn a constraint into an animation, but you can also do the opposite. You can turn an animation back into a constraint. So here is the animation that we just created, but the rig is not active. Now you can select the constraint itself and right click, and this time transfer motion to constraint. And if you do that, and yep, it applied that motion back over here onto the constraint objects. So the root object position and rotation, same thing for the tip. So now you can once again delete all of these ones that were created previously. And if you hit on play, and yep, we still have the exact same behavior as previously. So as you can see, you can go one way or the other way. Alright, so that's the animation rigging package. As you can see, it's full of features. This one is perfect for when you want to apply dynamic modifications to your animations. So as you can see, it's perfect for dynamic foot placement, or aiming exactly at where the player is aiming, or even some other things like, for example, grabbing a moving object, or maybe making a character touch the door while going through it. This is an excellent package that will make all your animations feel much more natural. Alright, so this was a lecture from my Ultimate Unity Overview course. There's lots more explaining tons of things like shader graph, assembly definitions, animation avatar, the video player, and so on, as well as many niche things that I couldn't possibly cover in normal YouTube videos. Go ahead and get the full course and learn how to master all of the Unity tools and features to help you make better games faster.